Let's take a closer look at reflection and see how we can apply our knowledge of the Cartesian plane and ordered pairs to understand this geometric transformation a little better. Here we have quadrilateral JKLM, and it was reflected in a vertical line of reflection through the horizontal axis at 5. Its reflection image is quadrilateral J prime, K prime, L prime, M prime. Each vertex moved horizontally, so the distance between the vertex and the line of reflection is equal to the distance between the image and the line of reflection. So, for example, this distance is 1 unit, and to the image, it is also 1 unit. Let's try this out. Let's look at vertex J to start with. So here is our table of values showing our ordered pairs for the vertices of quadrilateral JKLM and the vertices of quadrilateral J prime, K prime, L prime, M prime. The line of reflection is a vertical line passing through 5 on the x-axis, and the x-axis value for J is 1. 5 minus 1 equals 4. So this tells us that J, point J, this vertex here, is 4 units left of the line of reflection. And we can check that by counting the squares. 1, 2, 3, 4. But we could also figure it out just by saying that the line of reflection was at 5 and vertex J was at 1. The difference between those two is 4. So that tells us how far away vertex J is from the line of reflection. Now, equally, this should apply on the other side in the reflection image. Let's change colors here. So we start at 5 because we're at our line of reflection. And if we add 4, 1, 2, 3, 4, that takes us to 9, which is indeed where we find J prime. So 5, our point of reflection, our line of reflection, plus 4, the distance that we know our point must be from the line of reflection, equals our new x-axis value for the same point, J prime, the image. All right, let's try that out with the other vertices quickly here. For K and K prime, again, our line of reflection is at 5. K is at the x-axis value for K is 2. So 5 minus 2 gives us 3. So we know K must be 3 units away from the line of reflection, and counting does verify that. So we take that information. We're going to start at the line of reflection at 5. Then we're going to add those 3 units because we know K prime has to be the same distance away from the line of reflection as K, and that gives us 8, which is our new x-axis value for the image vertex K prime. And for vertex L, again, we start at the line of reflection, which passes through 5. We know that vertex L is at 4. We can see it right here in our ordered pair. 5 minus 4 equals 1. So we know that vertex L is 1 unit away from the line of reflection. So L prime will be 1 unit away as well. We start at the line of reflection, which is 5. Add 1 unit because we know it's 1 unit away. That gives us 6. 6 is our new x-axis value for point L prime. And last but not least, M and M prime. Again, we know our line of reflection is at 5 on the x-axis. Vertex M is at 3. 5 minus 3 equals 2. So that tells us that M is 2 units away from the line of reflection. We can count and verify that. Then to find the point M prime, we start at the line of reflection 5. We add 2 because we know that M prime has to be 2 units away because it has to be the same distance away from the line of reflection as its original. 5 plus 2 equals 7, and 7 is the new x-axis value for point or vertex M prime. So it's pretty cool how we can use addition and subtraction to help us find the ordered pairs of a transformation image, even without having to draw it. We just did it for a translation and now for a reflection. Now, let's talk about reflections a little bit more. After a reflection, a shape and its image face opposite ways. So they have opposite orientation. So an image that has a different orientation, definitely not a translation. The shape and its image are also what we call congruent. And we can show this by tracing the shape, as you can see here, traced in gray, and then flipping the tracing. And we see the flipped image right here. The tracing and its image match exactly, and that is what congruent means, that those shapes are exactly the same as each other.